Let's take a look at the 12 days of Christmas stuff. First question. On the first day of Christmas, true love gave to me a partridge and a pear tree. If the probability of getting a partridge is 0.58, and the probability of getting a pear tree is 0.76, and these are independent events, find the probability of getting a partridge and a pear tree. Okay, well, the way this works out is this is neither a binomial nor a geometric because there's not a fixed number of trials in here, and you're not looking for your first success. I mean, it's basically just saying the probability of getting a partridge and a pear tree. So in this case, basically, it's just going back to our definition of independence. It's take these two probabilities, multiply them times one another. So it is 0.58 times 0.76. Calculator 0.58, 0.76, 0.4408. So there's about a 0.4408 chance of getting a partridge and a pear tree. Okay, so now let's go through and just kind of figure out which is which. If the probability of a female turtle dove is 0.53, find the probability at least one female turtle dove in the pair. So this says at least one in the pair. What this is talking about, this is a binomial setting. And since it says at least one is saying probability that the turtle doves are greater than or equal to 1. So what you're going to do is you're going to say the probability is going to equal 1 minus the probability that your turtle doves are 0. So you're going to do a binomial setting here. You're going to do a binomial PDF. So this guy is going to be a binomial PDF. So you're going to go ahead and you're going to do 1 minus second bars binomial PDF. You got 2 birds. You get a probability of success of 0.53. And what is the probability you get none? So it's 0.7791, 1 minus. So in this case, what this says is the probability that you end up with at least 1 is about 77, almost about 78%. On the third day of Christmas, my true love gave to me the probability of exactly 2 French hens out of the 3. So again, this is going to be a binomial. And since it says exactly, this is also going to be a binomial PDF. I'm not going to go through the exercise of it in the calculator, but we have 3 French hens, 81 with French citizenship. We want exactly 2. So that's what we're going to do in the calculator. We'll type that in the calculator, we'll get our number. Answer key will be up online with the actual numbers. On the 4th day of Christmas, probability of a bird actually calling is 0.63. Find the probability of finding the first calling bird on the 3rd attempt. So this is a geometric setting. And since it's exactly, this is going to be a geometric CDF. I'm sorry, PDF, geometric PDF, my apologies. So since it's exactly, it's going to say the probability of success is 0.63. I want it on the 3rd attempt. So basically what that is saying is the bird doesn't call on the 1st attempt, the bird doesn't call on the 2nd attempt, the bird does call on the 3rd attempt. I'll do this one. It's a geometric ribbon done with it. Second bars, geometric PDF. So again, we're saying that it's 0.63, and we're doing it on the 3rd attempt. Paste that in, 0.0862. 0.0862. This was 0.0862. So it wouldn't be surprising if it took you till the 3rd bird to find the first one that calls. Okay, so again, we're going to kind of walk our way through, see if there's anything in here. If the probability of getting a real golden ring is 0.72, find the probability of getting 3 or fewer golden rings in the 5. Okay, so again, this is a binomial setting, fixed number of trials, 3 or fewer. It's actually saying was the probability that G is less than or equal to 3. So this is going to be a binomial CDF, 5 trials, 5 golden rings, probability of success of 0.72, and we want to get 3 or fewer. So we're going to go to calculator on that one. 6th day of Christmas, probability of an authentic laying goose is 0.83. Find the probability of getting a laying goose on or before the 4th trial. So this, it doesn't say first, but we want to get a laying goose. So we're looking until we get a laying goose on or before. So this is a geometric set, and this is going to be a geometric CDF. And the reason it's going to be a cumulative one is because we're saying before, on or before the fourth. So we're going to do 0.83. We're going to do 4, and that's going to figure out the probability of getting it the first time, the second time, the third time, the fourth time. All 4 individual events, add them up. That's what that's going to do. Seventh day of Christmas, if the probability of a swan drowning is 0.23, find the probability of exactly 4 out of the 7 swans drowning. It's a little dark, but we're talking about 7 total. So there's our fixed number of trials, exactly 4. We're talking a binomial PDF. Again, our trials are 7. Our probability of success is 0.23, and we want exactly 4. On the 8th day of Christmas, getting a sour made in milking, find the expected number. So in this case, this is going to be asking for a mean. So it's going to be either mean of binomial, mean of geometric. It says out of 8. So it's saying we're going to go out of all of the 8. So this is going to be that mean of a binomial. So it's going to be n times p. So it's going to be 0.38 times 8. If the probability of a dancing lady accepting invitation to the dance is 0.18, find the expected number. Okay, again, expected always tells me mean before one accepts. So in this case, we're doing it until our first success. So this is the mean of a geometric. And again, these are on your formula sheet, but the mean of a geometric is 1 over the probability. So you go ahead and plug in the probability of 0.18, and you find out it's, I think, 1 divided by 0.18. So that's saying on average, I would expect to have to talk to or ask about 5.5556 ladies until I found the first one to accept dance. If the probability of a lame leaping lord is 0.24, find the probability of getting your first leaping lord after your 6th attempt. Okay, so first tells me geometric. After your 6th says that I'm looking at this, the probability is going to be that we're doing the lords is after the 6th, so which is really the probability that the leaping lords is the 7th or later. But you can't do that in the calculator. What you need to do is you need to do 1 minus this. Because in the geometric world, we can only look down on CDF. So this is going to be 1 minus geometric CDF of 0.24, 6. Almost done. Where are our pipers piping? If the probability of frozen pipes is 0.63, find the probability of 8 or more frozen pipes out of 11. Again, this is going to be a binomial because we have that fixed number. We're looking at 8 or more, so we're going to say probability that our pipes are greater than or equal to 8. Well, we have to do 1 minus the probability that those pipes are less than or equal to 7, because again, it doesn't work in our calculator. Greater than only works less than. So this would be 1 minus a binomial CDF of 11 pipers. A probability of success is 0.63 and 7. That's what we got in the calculator. And last but not least, on the 12th day of Christmas, we have the probability of a dribbling drummer is 0.48. Find the standard deviation of the dribbling drummer drumming for 12 drummers drumming. So what this is saying is, again, we're saying a fixed number of trials. This is going to be the mean of a binomial, and the mean of a binomial is going to be, but again, all of this stuff is on the formula sheet. Just one last review. Here's your general formula for an exact number in a binomial. Here's the mean. There's a standard deviation. Here's your exact formula for a geometric. There's your mean. There's your standard deviation. So, hopefully that helps. Again, refer to the answer key. The answer key will give you the exact answers. Please ask me if you have any questions. And I hope it went well.